Right, today I'm going to be showing you three methods of extracting cross-sections. So up on my taskbar here, I've got cross-sections from DTM, cross-sections from strings, and cross-sections from points. So firstly, with cross-sections from DTMs, obviously you've got to have first some triangles created, which I'll display on here. So we've got a survey job here. We've got a triangular mesh, and what we've got also is an alignment, which is this red line going through here, which I'll be extracting cross sections from. So firstly, you go to design and cross sections from DTM. So I've got a preset alignment in there, which is that red line. It's called line 1. I go OK to that alignment, and it displays the extract cross sections from DTM screen. So I've got my alignment name, line 1. The start and end chainage is 226 meters long. The surface type is natural, and the surface name is natural. The DTM name is existing, because that's the only DTM I have. And then further down here, you have left and right offsets. So that's how far left and right of the center line in meters it will extract cross sections to. You can put in additional offsets if you wish. And include TPs basically means that if there is points along your alignment, you can extract cross sections at physical points. So, say for example, it was a existing road, and you picked up shots along the road, and you want to have cross sections at those points, then you would tick that option, include TPs. So when you tick it, it comes up with before, half angle, or after. In most cases, you set that as half angle by default. The default spacing means the spacing of each cross-section along the alignment. So you change that straight one, you could have it, say, set at 20 or 10 meter intervals. If I just set it at 10 meter intervals, and if I had curves, I would set that probably the same. In some cases, you might have quite a tight alignment. That is, the curves are fairly tight. So you might have 20 meters on the straight, you extract sections, and 10 meters on the curves. You don't need to really worry about cross sections at break lines, but this one down here, create CL points at DTM. So what that does, it will show on your profile the changes between the cross sections of the actual DTM surface. So you'll see points or points along the alignment there, where there is changes in the DTM surface. So what you done is, as soon as you've got this all set up, you click on the next button, and it brings up this additional chainages screen, where you can enter in additional cross sections or additional start chainages, where you want to throw in a couple of extra cross sections for design purposes, or you can put in a chainage value in there and click omit, and it will omit those chainages, those cross sections there. So in this case, I'm just going to leave that blank and then go OK. And as you see on screen there, it's shown where the cross sections are being extracted at. So in effect, what it does is with each one of those sections, and if I just turn on my mesh again and display that, then I go through and extract cross sections again, cross sections from DTM, using exactly the same settings of what I had before. Go OK. Next. OK. Now, where each one of those cross sections are extracted at right angles to the alignment, where it bisects the side of a triangle, it interpolates an offset and level. So each side of the triangle that this cross section slices through will be an offset and interpolated level at that position. Okay. So if you've got insufficient triangles, or the triangles are too widely spaced, you may have data missing from your actual natural surface cross sections. So when you've extracted cross sections, the next step is normally going into roads view. So you select the alignment, you open that up. Right, now we are in roads. So we've got 3 panels displayed in here. The plan view showing the alignment, the profile view, and the cross-sectional view. So in the profile view, I normally go to the red hot button down the bottom there and change the vertical exaggeration to say 5, but that is fully dependent on the topography of the land. So when we extracted cross sections, we ticked an option, include CL points. I'll just show you exactly where that was. So when we extracted cross sections from DTM, we created CL points at DTM. So back in Roads, what it does is basically shows you any changes between each of the cross sections. And that's a good example down here. You'll see a change in the surface between each sections. If we didn't tick that option, then it'll be just straight lines between each one of the cross sections. It would be missing out these little changes in the profile of the actual land. That would be going straight from there to there. So when you're extracting cross sections, I turned on in the red hot button there for sections, display point info, code, and display point mark. So all it shows in here is where it's cut one of the sides of the triangles, and it's called mesh. So that's the code it actually displays in there. So that is one method of extracting cross sections via the DTM method. It's the most commonly used one. So I'll close out of that now and go to another method that we use, and it's called cross sections from strings. So I'll open up that job. So here we have this job here. It's basically just a straight road, and we have a whole lot of lines joined together. This one being the outer extremities, being the fence line. We have ground level shots joined together as lines, and also the edge of the pavement and the edge of the shoulders, etc., and a water table. So we've got this alignment in here, and the difference between cross sections from strings versus cross sections from DTM is that when you extract cross sections from strings, it will interpolate a level and offset when it cuts the side of a string. So the more you intensify the shots out in the field, the more accuracy you would have. So therefore, because if you're extracting cross sections close to the surveyed point, then the levels or the offsets and levels would be very accurate. So what we've done in this particular example is I put a window around the whole lot of the data. I went into properties, and because they're lines, I've ticked both boxes there for break lines, so we're making those break lines. And now we go through to cross sections from strings. So click cross sections from strings, got my alignment here, alignment 1, go OK. Comes up a very similar screen with what you saw for the DTMs. You got alignment name, your start and end changes, the surface type or surface name is going to be natural. We've got our left and right offsets, which is 30 metres either side of the centre line. And we've got our default spacing set as 20 metres for the straight. There's no curves because it's a straight line. But again, if there was curves within your alignment, you would set that up accordingly, whether it's 20 metres or 10 metres. I've also ticked this option here, intersect break lines and generate road strings, because we've preset those as break lines. So you go next, same with additional changes to screen as what you saw before, where you can throw in additional cross sections or omit cross sections. Go OK, and it displays where the cross section has been extracted at, and the size of the string or the lines where it's interpolated and offset level. So now you go into roads view, so you go to design, roads, open up your alignment, and it will display the 3 panels being the plan view, the profile view, and the cross-sectional view. So first thing you do is go down to the red hot button, the display center down at the bottom of the screen there. You can display your profile, change your vertical exaggeration if you wish. I'm changing it to 5. And in the cross-section tab, I display point info, code, display the point mark, and go OK. The profile, I'll change that to green so it stands out accordingly. So there's the profile view there. And in this instance, it's not much change because we set it at a 1 in 5 exaggeration. But you'll notice in the cross-section panel area there now, there is codes associated with what the string line or the line that you cut. So we've got edge seal, which is edge seal left, edge emitter left, ground level shot, and a fence line left. On the right hand side, you've got the associated names for the right of the center line. Edge seal right, edge emitter right, ground level shot, and the fence line right. So with DTMs, when we extracted cross sections from triangles or DTMs, you remember it only showed mesh for each one of the points that are extracted cross section at. Whereas here, you've actually extracted cross sections that will show the code of what line work that you cut. So that's the difference with regards to cross sections from DTM versus cross sections from strings. So we'll now stop and go to the next option, which is cross section from points. Okay, here we have our cross section from points job displayed, and you'll notice on screen here that we've got our alignment down the middle of the road. We've got lines each side of the actual alignment, being the left side and the right hand side, and you'll notice that there's individual points, so there's no actual lines or strings joining those points, but just shots taken out in the field, virtually opposite where each one of the cross sections will be created at. So it doesn't matter if the points out in the field are slightly left or right of the actual right angles from the alignment, because we can actually encompass those points. So what we do is go to Design, Cross Sections, and you select on the down arrow button there, and there's an option there, Cross Sections from Points. Now this function, Cross Section from Points, is not widely used at all. Used to be in the past, but now it's basically the main options used for cross-section extraction is cross sections from DTM and cross sections from string. So you select the alignment, and it comes up with this particular screen. They're cross sections from XYZ or cross sections from points. We've got our alignment name, the surface type and surface name, natural, start and end chainage, and then on the right hand side here we have a tolerance distance and a tolerance required and the maximum offset. So what we do here, the tolerance distance is the distance out from the alignment, left and right hand side of the alignment, how far it goes, and then what it does is the tolerance required, which is 0.1 either side of the pointer and the center line. What it does is it draws a straight line from one corner out to the other, and then it basically draws a fan. So what we're going to do here is I'm going to be creating a sort of like a funnel shape zone or corridor to encompass the points in the cross sections. So I'm going to change the tolerance distance to be, say, 40 meters. A tolerance required, the tolerance distance is the 40 meters left and right of the center line, and any points included within that distance will be used. The tolerance required is, you imagine the corridor width either side of the center line point. So I'm going to change that to, say, 2 meters, and the maximum offset is 40. So either side of the center line we've got a 2 meter band, so basically it's a 4 meter band either side of that center line point, and it's going to be stretching out 40 meters to the left and 40 meters to the right. The chainage tolerance means that if your chainage points out the field, these are all preset. Say if you had preset points out in the field, and that's where you're extracting your cross sections at. When you start off your cross sections, say if the start changes with 0, then as you go along the alignment, those predetermined cross-section points will change. They won't be exactly 20 meters or 10 meters apart, and there will be a compounding difference as you go along the alignment. So this chainage tolerance means that if there is a point, say, at 39.85, as long as that change tolerance is a value that's greater than the discrepancy between the whole meter mark and the actual physical running change of the point, then it'll be included within the cross-section. So I'll just leave that as it is like that. And the zero offset tolerance means horizontally, if you're going along the alignment, if the cross-section points or the centerline points deviate either left or right, then it's concluded within that tolerance there. This section down here, cross-sections by code, CH mark or 555. Now, this was how they were coded many years ago, and this is a bit of a hangover from the previous software version that we had, which was called CivilCAD. So just leave that as it is. So you go OK to that screen, and it extracts the cross-sections and gives you a report on the points that are included within the cross-sections as we go along. So you'll notice that they're basically at 20 metre intervals, the points in the centre line there that are 20 metres apart, and those are the cross-sections there. So you close your report, and now go into roads. So you go to roads, open up your alignment to display the 3 panel views. Here we have the centre line, the profile here, and the cross-section. So I'll go to the red hot button again, change the display point info for cross-sections to code and display point mark. The profile, we could change the vertical exaggeration to say 5 and go OK. I'll just change the color of the profile. So the points picked up in the field are very similar to what cross-sections from strings did. And that is, the points that it selects out in the field there, those individual points, will be displayed as the code of the point. So it's edge meter left, edge meter right. So there was a string running along the left-hand side of the center line, which is that CH mark, and it happened to be edge meter left, and that's edge meter right. Same with that point there, the ground level shot. So as we go through the cross-sections there, it displays a little bit more information that's contained within the cross-sections. So that's the 3 different methods of extracting cross-sections. As I said before, the most preferred method that everyone uses these days is the cross-sections from DTM, and secondly, the other one is cross-sections from strings.